Good morning, everyone. Today, we are going to study the concept of supernode analysis. Based on this supernode analysis, we are going to solve some problems. So, this is the network given to us, and here you have to identify which is an supernode. And you see here, the voltage at this point and the voltage at this point both are connected in parallel. This will create a new voltage source, a new node V1. So, this is V1, and between this you got one resistor. Automatically this will create a one more node V2. So if this is shorted, automatic base also is shorted, V1 and V2 both are same. So since we have an extra resistor here, V1 and a extra node V2 is created. Now this is one more new node. So the voltage at this point and this point, the voltage at this point and this point, these two elements are connected in parallel. I can say this is going to develop a one more new node. But between two nodes, V2 node is one node, you have one more voltage source of 20 volts. Okay, so node is nothing but voltage. Okay, V2 is one voltage value, V3 is another voltage value. Between two nodes, node 1 and node 2, you have an extra node. So since due to this extra node, we are going to call this as a super node. Okay, so this is called super node. Okay, so here we are going to have the super node. So this node is called as a super node. Okay, super means is nothing but between the we have one extra node. If anything is extra, then you are going to call this as super node. So between the two voltage source V2 and V3, we are having one more voltage as extra. One voltage as extra. That's why these nodes are called a super node. Now let's try to use our analysis here to solve these problems. So coming here, so let's try to apply nodal analysis at V1 and nodal analysis at V2 and nodal analysis at V3, and automatically you can find out the V1, V2, V3. Okay, so here the problem given is apply supernode analysis for 20 volts source and determine the current through 5 ohm resistor. So he is asking us to find out the current across this 5 ohm resistor. Find the current across the 5 ohm resistor. You want to find out the current across 5 ohm resistor, then you have to find out V3, and current is leaving terminal is minus 10 divided by 5. So you have to find out this unknown value V3. So let's try to see the procedure of finding out. Okay. So now how to apply the supernode analysis? Redraw the same network. Okay. So whatever the network is given, you try to redraw the same network. And remove this supernode and make a short circuit between V2 and V3. So this value is of 2 ohm, this value is of 5 ohm, this value is of 10 ohm, and we have been created a short circuit between V2 and V3. So in order to apply it, so this is 1 ohm, this is 2 ohm, this is 3 ohm, this is of 10 amperes. So here we are going to have node V1, here you are going to have node V2, here you are going to have node 3. So now let's try to apply nodal analysis. Apply nodal analysis at V1 node. You see here, already we have, while applying the nodal analysis, the assumption is of this V1 is of higher potential. Current flows from this V1 to 0th node. So the current is flowing like this. Mark this current as some by 1. So current flows from V1 node to V2. Mark this current as some I2. So now when you mark it, when you apply the nodal analysis at V1, is nothing but applying Kirchhoff's current law. So apply Kirchhoff's current law at V1 node. So apply Kirchhoff's current law at node V1. When you apply the Kirchhoff's current law, so what are the entering currents? 10 ampere current is entering. What are the leaving currents? The current in this branch is nothing but I1. The current in this branch is nothing but I2. So how to write down this one? 10 is equal to, how to write down the current? I1. So current is leaving, or the leaving polarity, plus V1. So high potential V1 minus low potential minus 0 divided by 3 ohms, plus how to write down the current? I2. So we can write down it as V1 minus V2, V1 minus V2 divided high potential minus low potential divided by 2 ohms. So how I written this V1 minus V2 is current is leaving, or the leaving polarity of the voltage V1, and here it is starting and somewhere it is leaving, therefore the leaving polarity is minus V2. So when you are writing the nodal analysis, assume that this is of high potential, this is of low potential. Current flows from high potential to low potential. We are writing it as V1 minus V2 by R. If you are writing in the reverse direction, V2 minus V1 by R. So this is how we had written I1 and I2. When you solve it, you are going to get one equation. Now you see here. So now we want to apply the nodal analysis at V2, and which is also similar to that of an V3. Why? Because these are shorted. So I1, I2 currents are completed. Let's try to mark this current is I3 current, this current is some I4 current, the same will flow here, and this current is some I5 current, and this current is some I6 current. Now we need to apply nodal analysis, apply nodal analysis at which node? V2 node and V3 node. Why? Because both are shorted. So what are the leaving currents? So there is no entering current, but as per our assumption, all the currents will leave. That 0 is entering current, and leaving currents are, write down it as I3 is one leaving current. Next leaving current is I4 is one more leaving current to the branch V3. What are the leaving currents? So I5 is one more leaving current, and I6 is one more leaving current. So therefore you can write down 0 equal to, how to write down I3? Already I told how to write down the current I3. So V plus V2, current is leaving. What is the leaving polarity? Plus V2. And what is the ending polarity? Somewhere here it is. So V2 minus V1 divided by V2 minus V1 divided by 2 ohm. So how to write down I4? So I want to write down the current in this branch. So high potential minus low potential, V2 minus 0 divided by 1, plus how to write down the current I5? So with respect to which node we are writing? V3 node, same node I have to write down. Okay. So with respect to V3 node, V3 minus 0 divided by 2, plus how to write down the current I6 branch? So current is leaving, or the leaving polarity, plus V3, and current is flowing in 5 ohm, and current is coming to 10 ohm, or the leaving polarity we are going to have V3 minus 10 divided by 5 ohm. Okay, so when you are going to solve it, you are going to get the one more equation. Now we have been skipped this node. Okay, so now we are going to have an super node. Okay, so we are going to have the V2, this is, so now try to apply Kirchhoff's voltage law at V2 and V3 nodes. Okay, so when you're trying to apply it, you can see here we are having a V2 and we are having an voltage source. Okay, so this is positive voltage and this is negative voltage. Here we are going to have V2, here you are going to have V3, and in between here you are going to have 20 volts. Okay, so here I am going to have the 20 volts. And how to write down the current is flowing? This is positive terminal, somewhere negative. This is positive, negative. So how to write down the KVL? So current is leaving. What is the leaving polarity? So plus V2, and current is leaving this source. What is the leaving polarity? We have minus 20, and current is flowing like this. Okay, leaving is plus v2 minus 20, and next polarity is minus v3. So from these three equations, when you are going to solve, so try to use your calculator and express the equation in terms of v1, v2, v3. So this equation I can write down it as v2 minus v3 is equal to 20. So this equation I can write down it as 10 is equal to v1 I am taking common, which is nothing but 1 by 3 plus 1 by 2. So I am taking v1 term as common minus v2 by 2. So when you perform the analysis, you are going to get the equations for this. So this is equation 1. Similarly, you will be getting the equation in terms of v1, v2, v3, and you will be getting an second equation, and this will be an third equation. Use your calculators and try to solve it. Then you are going to get the v1 is equal to 18.948 volts, and v2 is equal to minus 8.420 volts, and v3 v3 is minus 8.34 volts, and v2 is 11.580 volts. So try to use your calculator and see that you are going to get these answers. And the question what it is asked, v3 minus 0 by 10 by 5, the current across 5 ohm. So now what is the value of v3? Minus 8.420 minus 10 by 5. So when you are going to perform it, this value is minus 3.684 amperes, and this current is flowing from top to bottom, and the current direction is like this, is trying to flow from top to bottom. So this is what the amount of current which is flowing in our circuit diagram. Let's try to see here. So the current is flowing from top to bottom as 3.6. So reverse also you can take, it can move from down to top, then you can write down plus 3.684 amperes. Okay, both are correct. Okay, now let's try to solve one more problem based on this supernode analysis. So hope you are able to understand the concept. So first apply nodal analysis at V1, apply nodal analysis at V2. So the combined nodal analysis you have to apply at V2 and V3. So apply nodal analysis V2 and V3, apply the nodal analysis at V1, then you'll get equation 1 and equation 2. So you had already shorted this. So in order to solve this super node, we have to separately write down the equations for V1 and V2. So separately I had written the equations for V1 and V2. Then I'm going to get third equation. Solve the three equations, then you can find out the different voltages at V1, V2, V3. So this is how to solve a problem whenever it is given this super node analysis. Now let us try to solve one more problem on nodal analysis. So here we are going to have a source like this. So the given source is an 10 volts and a resistor of 2 ohm, and here you are going to have 8 ohm, 2 ohm, and here you are having one source, and here you have one more resistive branch. This is of 6 ohm, this is of 5 volts, and you have one more branch heading, this value is 4 ohm. Okay, so these are the values given to us. This is values given to us. Now you can see here the voltage at this point is already known. What is the voltage at this point? 10 volts and 0 volts. One node voltage is known. So this will act as an another unknown voltage. Why? Because between 10 volts and V1 there is a resistor. Automatically it will create some drop. Therefore this voltage and this both are not same. So this will act as a new voltage V1. And here also voltage is a new voltage will be formed, which is nothing but V2. Now let's try to apply super node analysis. Okay, so now the question is asked, find the nodal voltages. Okay, he's asking us find the values of V1 as well as V2. Okay, so we need to find, otherwise you just mark this value is some V1 for your understanding, and this is some V2, and this is some V3. Already given that for your analysis V1 is equal to 10 volts. Now the unknown nodes are V2 as well as V3. So how many unknown nodes we are going to have is only V2 node. V2 is unknown and V3 is asking us to find out V1, V2, V3, and already V1 is specified in the problem. So now how to find out? Try to apply the nodal analysis at this node. Okay. You see here current is leaving this branch, mark this current as some I1. So current is leaving this branch, mark this current as some I2. Okay. And here what you have to do, you have to short circuit this one. Okay, and you have to apply. So I'm going to redraw the network for more clarity. Okay, so how to redraw it? So you are going to have a 10 volt source and one resistor and one more resistor, and this sources is short circuited, and you are going to have 6 ohm, and the top you are going to have one more resistor. So this is of 8 ohm, this is of 6 ohm, this is of 2 ohm, this is of 10 volts, and this is of 4 ohms. So this is V1 and this is V2. So why means, so we have to short circuit the 5 volt source where this V1, V2, V3, where this branch is called super node. Super node. Why super node? Already you know clear. This is one voltage, this is another voltage. Between two voltages, one voltage is extra. That's why one voltage is extra. Therefore, these nodes are called super node analysis. Between two nodes, we have one extra node. Therefore, these analyses are called super node analysis. So first, we have to short circuit that voltage source, and you have to find out the currents. So let's try to find out the currents. So see here. So assume that when you apply nodal analysis, this is of high potential. Current flows from high potential to low potential like this. Current flows from this, mark this current as some I1. So mark this current as some I2. Current flows from high potential to low potential, and the current will not flow here. And coming to here, next, what are the branches connected here? And the current in this branch is I3, and the current in this branch is some I4. So now let's try to apply nodal analysis at V2 and V3. Why? Sorry, at V2 and V3, which are same. Okay. So when you are trying to apply here, what happens here is what are the entering currents? 0 is entering current. What are the leaving currents? I1 is one leaving current, plus what is the next leaving current? I2 is another leaving current. Next leaving current is I3, and next leaving current is I4. So now I can write down 0 is equal to, how to write down the current I1? This is flowing from V2 to this branch. So V2, and current is going through 2 ohm and coming like this. Okay, so V2 minus 10. So what is the leaving terminal? V2 minus 10 divided by, what is the resistive branch? 2. How to write down the current I2? So this I2 can be written as V2 minus 0. So V2 minus 0 by 8. So how to write down the current I3? So coming to this, these are both are same. So how to write down the current? This is high potential, this is low potential. The current I3 is flowing like this in this branch. How to write down I3? V3 minus 0 divided by 6. How to write down the current I4? So how to write down this current? How to write down this current? V3, and what is the voltage at this point here? So V3 and 0. The I4 current is flowing like this to the 0. So V3 and current is, what is the leaving polarity? Minus 10 divided by 4. Okay, so separate V2 terms and V3 terms separately. Then you are going to get V2 of 0.625 plus V3 of 0.416 is equal to 12.5. So just separate V2 terms and V3 terms. Now already we have been short circuited V2 and V3. So this is V2, and we already have a source between these two. This is positive terminal and negative terminal. This is V3. So this is positive and negative. This is positive and negative. The voltage value is V2. Now we already shorted here, and you consider this now. You can try to, so how to link V1, V3 and these three nodes, where between two nodes, V1 is one node, V2 is another node. Between two nodes you have one extra node. Then you are going to construct like this. Therefore current is leaving, what is the leaving polarity of the voltage? Plus V2. Current is leaving, what is the leaving polarity of the voltage? Minus 5. So current is flowing like this. Current leaving is plus V2, current leaving is minus 5, and current leaving is minus V3. So from here you can write down V2 minus V3 is equal to 5. So this will act as equation number 2, this will act as equation number 1. So try to solve equation 1 and 2. So then the question asked is V2 is equal to 14 volts and V3 is equal to 9 volts. That's how it is asked. So application of supernode analysis. Okay, we have to find the values of V1, V2. See this here. So this voltage is already given. Therefore, this V1 value already given in the problem is 10 volts. So this will act as a new node, which is I am labeling as V2, and where this I am labeling as V3. And how to do the problem is, first you short circuit this, deactivate the source, and try to perform your nodal analysis across V1 as well as V3. Next one, what I have to do is, so now you consider the same branch again. So consider the same branch where V1 is a one voltage source, V2 is another voltage, and between two voltages you have one voltage is extra. So since one extra voltage is there, okay, so this extra voltage or extra node is there, therefore this is called as a super node analysis. Okay, that's how to understand this super node analysis. Okay, let's try to solve one problem. So actually seeing this lecture or seeing this content on the online will not help you. So first, what is the procedure of solving is, try to see the procedure how I am solving the problem, and close the book and write down the given question as it is, and try to solve of your own. And if any mistake goes wrong, you can see from the lecture. See that you should able to do the steps of your own, then only the things will become very clear. This is not like by seeing you'll get supernode analysis, you're able to solve supernode problems. You have to see the procedure, learn the concept, and take the problem and try to get the same answers how I get it. If you are able to do of your own only, the concept will reach you. So hope, let's try to take one more problem to understand this super node analysis. So here in this question, what it is asked is, so the third problem. So third problem, what it is asked is, find the values of V1 and V2. Find the values of V1 and V2 and the current across a 2 ohm resistor for the network shown below. Okay. So the network given to us is like this. So this is an 7 volts, this is a 4 ohm, this is a 3 ohm. In between this you have one super node, this is V2, this is V1, and this is, and he's asking us this current, and this is connected in one more parallel. The value of this is 6 ohm, the value of this is a 2 ohm, and this is of 3 volts. So this is the problem given to us, and you can see here, as per the given problem, the voltage at this node is 7 volts, the voltage at this node is 0. So this will act as an new node, this will act as an new node. Why? Because between this you have source. So now this will be acting as an super node. Okay, so this will be, this is one voltage, this is another voltage, and between two voltages we have one more voltage extra. So this extra voltage we are going to call it as a extra voltage. This extra voltage we are going to call it as a super, and these voltages are called as, this voltage V1, V2, V3 are called as nodes. That's why this comes under the problem of super node analysis. There the super node exists. The procedure of solving is, first deactivate the super node concept. So deactivate 3 volt source. Deactivating this source means making the source as V equal to 0. So how to make this 3 volts as 0 is just by short circuit. So if you short circuit it, automatically R will become 0. So redraw the given network. So this will be node V1, and you are going to short circuit here, and you are going to have V2 here, and here you are going to have like this, and one more branch you are going to have, this is 6 ohm, 2 ohm, and we need to find out the current across the 2 ohm resistor. We need to find out V1 value, as well as we need to find out V2 value. So this given is 7 volts, 0 volts, this is 4 ohm, this is 3 ohm, and we already shorted here, and we need to find out these values. So trying to apply the, already it is shorted, let's try to apply the nodal analysis. So when you're applying the nodal analysis, assume this is of high potential, then current flows from high potential to low potential. Mark this current as I1, mark this current as some I2, mark this current as some I3, mark this current as some I4. So as per our nodal analysis, no current is entering, and so we are going to apply nodal analysis at V1 and V2. So now you see here how the, what are the entering currents? No current is entering. Enterings are 0. Leaving currents are, so I1 is the one current leaving the node. The next current is I2 is the next leaving current. Next you have I3 is the another leaving current. Next you have I4 is the another leaving current. So from here, see here how to write down I1, how to write down the I1 current. So current is leaving. What is the leaving voltage? 0 is equal to V1. Okay, mine, I mean V1, it is traveling like this, and it is traveling here. And what is the leaving polarity? Minus 7. High potential minus low potential divided by R. R value in the branch is 4 plus. How to write down the current in this branch? Already told, high potential minus low potential by R. What is high potential? V1 minus 0 divided by 3 ohms. How to write down the current I3 in this branch? V2 minus 0 divided by 2 ohm. How to write down the current I4 here? V2 minus 0 divided by 6. Separate the terms. We are going to get V1, so V1 by 4 minus 7 by 4 plus V1 by 3 plus V2 by 2 plus V2 by 6. So when you do it, you can see here, you can separate V1 terms, and we can separate the V2 terms. So we can write down V1 of 1 by 4 plus 1 by 3 plus V2 of 1 by 2 plus 1 by 6. So this is minus 7 by 4. Here you are going to get plus 7 by 4. So when you are going to solve it, you are going to get v1 of 0.58 plus v2 of 0.66 is equal to 1.75. This will act as the equation 1. So coming to the second equation, so already we are having the nodal analysis. So we are having an V1 node, and between this V1 we are having an V2 node. And what is the voltage of this new node? 3 volts. So this is a positive terminal, negative terminal, positive terminal and negative terminal. Now current flows in this direction. This side. So as per this, apply the Kirchhoff's voltage law, and as per the Kirchhoff's voltage law, the current is leaving. What is the leaving polarity? Plus V1. Current is leaving. What is the leaving polarity of the voltage? Plus 3. And current is leaving. What is the leaving polarity? Minus V2 equal to 0. So V1 minus V2 is equal to minus 3. So this will act as the equation 2. Solve using your calculators 1 and 2. Therefore, when you solve it, you will get the value of V1 is minus 0.184 volts, and V2 value you are going to get 2.81 volts. And in the problem, it is asked the current across which one? 2 ohm resistor. So what is the current across the 2 ohm resistor? How to find the current across the 2 ohm resistor? So the current across the 2 ohm resistor, is V2 minus 0 divided by 2. So the value of V2 is already obtained, is 2.8101 by 2. Okay, so this will give the value of 1.405 amps. So this is how. Very simple. So this is known, this is unknown, this is unknown. Between two node or two node voltages, you have one more voltage source. That's why this will act as an super node. I'm repeating the problem for more clarity. So all the current will travel I1, and this current is I2, and this current is I3, and this current is I4. So we are going to apply the nodal analysis at V1 and V2 and express all these voltages. The form current I is equal to high potential minus low potential divided by high potential minus low potential by R, or in the form of V by R. Then we can get one equation. So how you got this equation, and similarly you consider that super node concept between V1 and V2 and try to apply the KVL, then you'll get one more equation. Solve one first equation, second equation using your calculator, then you can get the values of V1 and V2. And in the problem it is asked, find the current across the 2 ohm resistor. The current across 2 ohm resistor, how to write down this current? V2 minus 0 divided by 2 ohm, then you can find this current. So hope you are able to understand the concept of super node analysis. If you feel the content is useful to you, please give a like and subscribe to the channel and share to your friends. So hope the content is useful to you, and directly by seeing this video you will not get anything. Just see the video, see the procedure, and write down the same problem and try to get the answers of your own. If you are able to get the answers of your own, then automatically you can understand the concept. Hope the content is useful to you. Thank you, yours Ram. Thank you.